Now let's find a position for an angle of 45 degrees. So we know we need to start at the horizontal line and go either up, get to the point A, or we need to go down 45 degrees and find a point B. The question is, which one corresponds to 45 degrees and which one is not? Or both of them correspond to 45 degrees. Well, you can argue that the actually point A is 45 degrees angle. And, the argument can look like, well, that's what we did so far, and you'll be right, but it's not really a very good argument. A little bit better argument is we know that sine of 45 degrees should be a positive number, because 45 degrees we can get from a right triangle. And the sine in a right triangle is this ratio of the sides of the triangle, and that should be positive. So now if you really look at positions A and B, you find the position of point A. Vertical position is positive, so sine is positive. Vertical position of a vertical coordinate of point B is negative. So really it tells us that probably point A corresponds to an angle of 45 degrees. Right, and you'll be right. But now the question is, what is point B? If I'm measuring 45 degrees down, what am I going to get? And by convention, people decided to call it negative 45 degrees. So every time when we going counterclockwise, we're going to add positive numbers. When we go clockwise, we're going to add negative numbers. So the point A, vertical coordinate, will be sine of 45 degrees, and vertical coordinate of point D will be sine of minus 45 degrees. All right. So let's just concentrate just on 45 degrees, okay? And let's just think about different ways how we can get to point A by going around in circle. One way just go straight from horizontal line going counterclockwise, so we get 45 degrees, like we showed before. But that's not the only way. Really what we can do, we can go this 45 degrees, get to point A, and then complete another counterclockwise circle around and come back to point A. Well, the angle we're going to get eventually in this case is not going to be 45 degrees. It's going to be 45 plus 360 degrees. Okay? It's going to be 405 degrees. And that angle again gives us the point A. I mean, we don't have to stop at one circle. We can go for another circle. In this case, we're going to have take 45 degrees and add 360 degrees twice, and we get an angle of 765 degrees. And we can keep doing this and going another circle, another circle, another circle. And every time we're going to add 360 degrees, and our angle is going to grow. Now, we don't have to go up, though. We can actually go down. We can go clockwise. And as we talked a little bit earlier, when we're going clockwise, we're adding negative numbers. So if we were at 45 degrees and decided to make a circle clockwise, we're going to subtract 360 degrees and get to the angle of minus 315 degrees. Again, we can do it again. In this case, we're going to subtract another 360 degrees and get to minus 675 degrees. But notice what happens here, that no matter what we do or what we did, we always get to this point A, okay? And when we talk about definitions of sines and cosines, we said that really sines and cosines should be coordinate of this point A, okay? So really what we see now that for all these angles, sines and cosines are going to be the same. So now let's just assume, just make it more general statement. Let's assume you have angle theta, not necessarily 45. Theta definitely could be 45, it could be anything else. And what we talked about before, we said that, well, if I take angle theta and add or subtract 360 degrees several times, I'm still going to get to the same point A as I had originally. So the angles we're going to get by going around, taking angle theta and going 360 degrees, either clockwise or counterclockwise, could be written by the formula you see here, theta plus 360 degrees times n, where n is any integer, 0, plus minus 1, plus minus 2, whatever you want to do. Okay? The other way mathematically people like to write the fact that n is an integer is by simply saying n belongs to the that letter z, which indicates the integer numbers. All right? And once we did this, we can simply say that if I look at the sines and cosines of theta plus 360 degrees times any integer number, I'm still going to get sines and cosines of theta, okay? It doesn't really matter how many times I go around the circle and how many times I add or subtract 360 degrees. So that kind of should make sense now. It also you should understand that in general, when we talk about algebra, especially when we talk about angles, angles could be really a number, any real number, from minus to plus infinity. But there's a relationship between those numbers. So every 360 degrees we coming back, and trigonometric functions repeat themselves. So trigonometric functions are going to be periodic, is a period of 360 degrees when they repeat themselves.